it's a total solar eclipse today, where the moon passes in front of the sun almost completely. If you're in a certain part of the country, you'll see it completely cover the sun, called totality. If you're lucky enough to see that, then you can see the corona, which is the sort of outer atmosphere of the sun, which is normally invisible to us because the disk of the sun is so bright. So I'm going to try to video the solar eclipse if the clouds participate with us. Basically, I'll slide this telescope onto here, align it with the north celestial pole, and then try to find the sun. And then if we hit a button, then it should track with the motion of the Earth rotation. So this thing is supposed to be able to track with like less than 1 degree of error. And one degree is about the size of, I don't know, like half the size of a star if you're looking at it, so it's extremely small. I mean, without this filter, essentially it's like pointing a magnifying glass at the sun. Imagine, if you're a kid with a magnifying glass and going after ants or something, imagine turning it around on your eyeball. That's basically what you're doing if you don't have the filter on. So it would destroy my camera and everything. There's many different types of telescopes. This one's a refractor telescope, so those are like big camera lenses. And NASA uses a ton of those, but they also use reflector telescopes, which are the most commonly used ones, and they have no glass elements in them. They just use mirrors to reflect the light, and that's what all the big fancy telescopes are. But those come at a cost because the mirror has to be much bigger because there's no bending of the light, it just reflects it. And so things like JWST and the Hubble Space Telescope, those are reflectors. And so this one just uses lenses instead of mirrors that most NASA scopes use. So this happens multiple times a year throughout the world, but in North America, I think it hasn't happened in several decades. So it's a special day.